Fine. No, that's fine. We've got those 5 minutes extra before we were taking questions. So I think it works out perfectly. Lena, do we have you online ready to go? Brilliant. So then you'll be talking.
I'm here.
Technological signatures in rock art, insights from Timna in detail. Are you able to share your screen?
Yes, I do.
Fantastic. Please take it away.
Thank you. Good afternoon. So since I was introduced, let's start away. So I'm from Computational Archaeology Laboratory, Hebrew University. Today, I will be talking about the technological aspects of rock engravings. The research that I will present here made by Professor Leor Grossman, Marcelo David, and myself. I will be showing that we can study ancient rock engravings with computational methods. I want to demonstrate how we can do it. Our study case will be engraving and graffiti found in Timna Park, Israel. The method will be computational. I will walk you through the process of computational analysis of 3D models of engravings with ArcCAD 3D software, especially developed for this. As a result, I will show how the micromorphological characteristics, together with computational data, can lead us to technological recognition and to understanding of variation in technique implementation. I will also show that through computational data, we can make assumption about the level of skill involved in the execution and even hypothesize about the possible geographical origin of the individuals or communities that produce the engravings. The field of rock engraving is perhaps the most prominent of archaeological fields, which advocating the visuality as a research tool, using the iconography, iconology, and stylistic characteristic, and recognizable signifiers and attributes. So it proved to be a field with a significant methodological link between art history and archaeological disciplines. That said, during the last decade, and following development of new documentational and analytical methods, the focus in archaeological rock engraving research began shifting from images towards the making and materiality. This includes the analysis of singular cuts section along the engraved line and the analysis that allow to see the lines in the profiles, or the analysis of directionality of sequences, while the researchers consider overlaps of engraved line as indication to the order of the engraving actions. So now is to my personal motivation. The research angle that I present here is a result of my practical experience in field of craftsmanship. I am an artist and a craftswoman, and my focus in my practice is on sculpturing and engraving of surfaces. I believe that those who involve in making the material object see object made by others in a different way than those who approach the material culture from merely theoretical point of view. The practitioner will always focus first on the know-how and on the evidence that curates the process, inquiring how something was done and what materials and tools were used. I joined the Computational Archaeology Laboratory heading by Professor Leor Grossman at the Hebrew University as a research student. This laboratory main focus on development of advanced methods which allow to research the manufacturing processes with computational tools. The relevant question for studying the engraving technological gesture were, what can we do in cases where there are no overlaps? Or what if we will analyze not two-dimensional cuts, but three-dimensional slices? What if we will be able to see all the slices in a continuous way as a sequence? As a case study, Timna Park, located in southern Israel, contains remaining of copper industry spread across no less than 500 years. On the right, you can see examples of finding in the park, a worship site, and smelting and mining sites. And the question, who managed the copper mining and smelting work when they been at their peak? So according to Ben Rothenberg, Egyptian New Kingdom, who used the local tribes as labor force. And recently, it was shown by Erzman Youssef that only the early stages of copper production were managed under the control of Egyptian New Kingdom. The peak was actually during the period when it was controlled by semi-nomadic tribes and groups as proto-state of Edom. I will talk about the engraving of Timna Park, mainly from site 25, with a mentioning of site 200 at the end of this presentation. Each of the rock engraving found in Timna considered to be unique examples, as no formal connection between them found. And this is our team, the computational lab team, who went down to Timna several times in order to 3D scan the engravings. We used the structured light scanner for location, where we were able to place its tripod. For harder to approach area, we used handheld mobile scanner. We scanned 8 different engraving clusters and groups of intentional rock marks, and back in the lab, analyzed each engraved line they contain. While the analysis being made on large data sets, here I will be presenting only a sample out of it, 2 large engravings and modern graffiti, all from site 25. Here you can see the tracing of 3D models on the right and the models of chariot engravings, the ibexes engravings, the largest ancient engravings on site. And at the bottom, a modern graffiti gigi, an engraved modern Hebrew name, assumingly left by one of the visitors in the park. Now, this is how the 3D model of the chariot engraving looks like. An original software, ARCAD 3D, was created for this research. It allows to repeatable and accurate analysis of rock engraving surfaces through digital 3D models, extraction of continuous sequence of 3D slices from the models, and extraction of computational information from the slices. Thus, we can mathematically analyze this engraving. Not less important, it is meant to be approachable to an audience of archaeologists and art historians with no 3D background. This is the software interface. You can see the 3D model on the left and the function on the right of the screen. After the automatic positioning, the user can manipulate the orientation. The new positioning can be saved for later reproduction. You can also navigate and zoom in into the model. To start the analysis, the user selects 2 points on the mesh model with the mouse, or manually insert X and Y coordinates, and a list of points is created. It can be saved for later reproduction of the analysis. The 3D slices then extracted from between these points following a calculated path. The 3D slices can be extracted using minima path or straight line and in a chosen tolerance, which means the thickness of each slice. After the slicing, it is a turn for the analytical stage. The computation information can be extracted using the Analyze Slice button. Here we see 3D slicing between two points. It's somehow similar to the slicing of a cucumber. Every slice has 3 dimensions. In the pop-up window, each graph represents one 3D slice. So you can also take all the slices of the cucumber and put them back together. So it's a way to extract the information in a continuous way. What you see here is the automatic sequence, AS, the whole cucumber together, and I can rotate it in order to understand it better. I can also see each of the slices separately and one after the other, like an animation sequence. What do I get at the end? Computational and morphological characteristic. One of the most indicative morphological characteristic is a minima point on each slice, the lowest or deepest area in each slice. We call it MP. We're following their count and placement on the graphs. Another is a combination of all the slices, automatic sequence. We call it AS. The technique recognition is a combination of the number of minima points and the general shape of the slice. Here we can see differences in the shape and the number of the lowest points. I say that we don't look only on one slice, but on their combination and on the computational parameters, which I will show in a bit. So do you remember the animation of the slices? Here you can see how we can draw understanding from the sequence. I am showing here a sequence of only 10 slices, that is 10 millimeters, while in fact we've been analyzing hundreds. So you can see the first and the last slice on the sequence extracted from 2 engravings. You can see how that shape of the slice changed between the first and the last slice. Now, all the slices on the sequence. In the chariots, you can see how another minima point entered, and the changes are far in between when compared to the example of ibexes. In ibexes, there are much more changes through the same length, but even in the ibexes, you can still recognize continuity between several slices until more dramatic change occur. That means that we can recognize separate engraving gesture. We see longer engraving movements on the top example and shorter on the bottom. This is because each gesture creates different minima point. So that's for the morphology. And additionally, we extract the computational parameters, angle, depth, and width in each slice. As a result, the slice is presented in a relative scale, enhancing the form of the slice. And in true-to-scale mode, both graphs contain the representation of the slice angle. The extracted depth and full width at half maximum are presented on the right. The top number represents the number of the slice on the AS formed by combining each distance from the selected start point and the chosen slicing tolerance. What are we doing with the computational information? We extract average and standard deviation, which allow us to follow the particular implementation of each technique. Here, let's compare line made by the same technique, the stroking technique, in 2 different engravings. Notice that the standard deviation is low in the chariots and high in Gigi. That means that the chariot lines show much more consistency, which means that the engraver gesture were much more similar to each other. And then we count in the minima points in each slice. We can see that in the chariot, it has 1 or 2 minima points, while in Gigi, the MP count show much more variation. That means non-regularities. So when we look at the distribution of MP points along the slices, we find that, again, we can see regularities in the chariots and no regularities in Gigi. So the chariot showed steady mark making. Gigi graffiti showed large fluctuation in frequent changes, as the assumption is that regularity reflects skill and mastery of the technique, consistency of measurements, and in MP count along AS reflect skillful execution. We can see 2 implementations of the stroking technique, one with regularities and one without regularities, which show messy and wobbly execution slice, and there are need to compensate for inability to create steady visible mark. That means that by computational analysis, we can distinguish between skillful and unskilled engraving acts. In this slide, I have previously compared between chariots and ibex techniques. In chariots, we have stroking technique. The ibex figures were executed by applying a multiplicity of short peeling strokes placed side by side. There is continuity of the MP along several millimeters that is different from the pecking technique, which composed from focused hits, which reflected non-continuous minima points. Computational data showed similarities along long sequences that we find here a skillful execution in both techniques. Now, Here's an example from an animal figure in both chariots and ibexes. Along the research, we discovered skillful execution in both by recognizing regular and consistent patterns. The regular and consistent patterns in stroke application in the examined section probably resulted from prior experience in inscribing rocky surfaces. This means that we can assume that this experience is a result of natural surrounding condition, wherever the engravers originated from. So as to ibex engraving, if we're assuming prior experience and looking into the possible logic of using the peeling technique, we can link the peeling technique to the adjusted Negev area. In Negev, where the rock are covered in dark patina, engravers peeled off the dark coating during the engraving operation, exposing the light color underneath, as shown by Anati. We're proposing that the use of the peeling technique in Timna ibex engraving can hint at the engraver's production habits, despite the absence of dark patina on the Timna rocks. Same here. If we're assuming prior experience and looking into the possible logic of the stroking techniques that dominating the chariot engravings, we can propose that in patina-free areas where the color of the rock was uniform, the engraving action was done so that the incised element created a shadow, thus making the lines visible. This we can find in the engraving found in Sinai patina-free areas, like in the example here from northern Sinai. So we are basing here on the other researcher photographed reports that the quality of the photographed images is low compared to the 3D scan models on the left. I'm sorry about that. I hope you're still able to see. So as we suggest that the regularity of the execution highlights the engraver's level of expertise, skill, and previous experience, our hypothesis that a skillful execution stems from previous experience in stone engraving and outside the boundaries of Timna Park. So geographical and geophysical conditions led to the development of different technical traditions as evidence from different ethnic groups that passed through Timna over time. Here, I have introduced only 2 ancient engravings, but during the research, we defined computationally on site 25 alone 5 techniques with 3 distinctive variations in the stroking technique. Given the variety of techniques identified, site 25 titled by us as a local laboratory of intentional rock mark, stating the rich variety of groups passing through and maybe inhabiting the area. What have we learned from this site? That we can achieve through computational parameters and morphological characteristics, not only technique recognition, but also detect the skill degree by recognition of the consistency of the execution mode, and then we can hypothesize the geographical origins of the engravers. So what are we doing now? We are working on understanding how social organization impose engraving techniques and the mode of their implementation. We recently did an extensive comparison of stela engraving and the chariot engraving. On the right, you see a detail from the chariot engraving with the variety of techniques here used to create it. So chariot has 2 techniques, and in case of the stroking technique, it has 3 different implementation modes. And this is, by the way, consistent over the whole engraved scene. We found that in stela, which is clearly Egyptian formal engraving, contains 1 single technique, the hammer and chisel technique, as illustrated here. We are working to show now how different level of social complexity can be connected to the differences between the engraving methods. The decision as to which technique to use for which element is a part of the engraving process, allow for integration between variable engraving techniques versus the standardization of the engraving method that result in adoption of formal, uniform engraving protocol. And so as a consequence, we can discuss the possibility of identifying the fingerprints of the manufacturing societies. Thank you.